In the final years of World War II, a sound no one had heard before tore through the skies, a shriek faster than thunder. Allied pilots were stunned. What was this weapon of the future? It wasn't a rumor. It was real, and it changed aviation forever. In the summer of 1944, the skies over Europe began to change. For years, the roar of piston engines had defined the rhythm of war, the deep thunder of Allied bombers, the growling response of German interceptors. But then came a new sound, sharper and stranger. It wasn't the familiar growl of a propeller. It was a scream, a metallic howl that cut through the air like tearing steel. Pilots who heard it for the first time couldn't believe what they were experiencing. Some thought it was a new kind of bomb, others a ghostly echo. It was neither. It was the sound of the world's first operational jet fighter, the Messerschmitt Me-262, and it had just rewritten the future of flight. The Me-262, known to German pilots as Swallow, looked nothing like the sleek, prop-driven aircraft the Allies had come to know. Its engines were mounted under its wings. Its nose sloped like a hunting hawk's, and when it accelerated, it didn't climb so much as vanish. Allied pilots who tried to chase it found themselves stunned. Their planes simply couldn't keep up. The Me-262 could fly over 100 miles per hour faster than any Allied fighter in the sky. It could strike a bomber formation and disappear before escort planes even turn around. For a moment, Germany had achieved what Hitler craved most, a weapon that seemed untouchable. But technology alone doesn't win wars. And though the Me-262 was an engineering marvel, it was born from desperation. Germany, cornered by relentless bombing and dwindling supplies, had poured its last hopes into what it called Wunderwaffen, wonder weapons. Jet aircraft, rockets, and guided missiles were meant to turn back the tide. Yet every one of these projects carried the same curse: brilliance trapped by chaos. The Me-262 story began years earlier, long before war turned the skies into killing fields. As early as 1939, German engineers at Messerschmitt had dreamed of harnessing jet propulsion, a technology so new that even scientists struggled to understand it. Traditional aircraft relied on propellers to pull them forward. A jet, however, worked by forcing air through a turbine, compressing it, igniting it, and expelling it at tremendous speed. The result was thrust, pure, continuous power. It promised unprecedented performance, but demanded materials and precision Germany could barely afford once the war began. Despite these challenges, two young engineers, Hans von Ohain and Ernst Heinkel, pressed forward, experimenting with early prototypes. Their engines worked, but just barely. They ran hot, failed often, and consumed fuel at terrifying rates. Still, when the Messerschmitt Me-262 took its first successful flight in 1942, it represented the most radical leap in aviation since the Wright brothers. The dream of faster-than-sound flight didn't seem impossible anymore. Inside the Luftwaffe, the reaction was electric. Test pilots described the Me-262 as smooth as silk and as fast as a bullet. It climbed effortlessly and handled like no plane before it. Even its flaws, sluggish acceleration, fragile engines, couldn't overshadow the sensation of flying something decades ahead of its time. But when the aircraft was presented to Hitler, the story took a darker turn. Obsessed with offense, Hitler insisted the jet be used not as a fighter, but as a fighter-bomber, a decision that crippled its development. Engineers protested, arguing that the Me-262's speed and agility made it ideal for air defense, but their objections fell on deaf ears. Time was running out, and Germany's leadership was blinded by the illusion of superiority. By 1944, Allied bombers were hammering German factories day and night. Fuel was scarce, skilled pilots were dying faster than they could be replaced, and the Luftwaffe's once-feared reputation was collapsing. Yet when the first Me-262s appeared in combat, they reignited a spark of fear in Allied hearts. The jet could tear through a bomber formation before anyone reacted. American aircrews reported being attacked by silver arrows that came from nowhere. Their guns couldn't track fast enough. By the time they fired, the jets were gone. For Allied commanders, the reports were alarming. They realized they were witnessing the future, a future where conventional aircraft would be obsolete. The Me-262 was proof that Germany still had the power to surprise, even as its cities burned. Intelligence officers scrambled to learn everything they could. How fast was it? How did it turn? How many were being built? No one knew for sure. But one thing was clear. If Germany could produce them in large numbers, the skies over Europe might tilt in the Reich's favor again. Fortunately for the Allies, Germany's technological edge came with fatal flaws. The Me-262's jet engines, the Jumo 004, were masterpieces of innovation but disasters of reliability. Built from cheap alloys due to shortages of high-grade metals, they lasted only about 25 hours before burning out. Mechanics often had to replace entire engines after just a few missions. Jet fuel was another nightmare, scarce, volatile, and inconsistent. Even training new jet pilots became nearly impossible. The Luftwaffe's veterans were gone, replaced by teenagers with barely 20 hours of flight time. These young men climbed into aircraft that demanded absolute precision, flying at speeds their reflexes couldn't handle. The Me-262 was faster than its pilots. Still, in skilled hands, the jet could devastate the enemy. A single burst from its 430mm cannons could shred a bomber. On April 19, 1945, ace pilot Hans Fay shot down 4 Allied aircraft in minutes, proving what the Me-262 was capable of. But for every success story, dozens of jets sat idle, grounded by lack of parts, fuel, or pilots. Allied airstrikes targeted the runways themselves, knowing the Me-262's Achilles heel was its vulnerability during takeoff and landing. Many were destroyed before their wheels even left the ground. To the Americans watching from above, the Me-262 became both a symbol of fear and fascination. It was a glimpse into the next war, one they were determined to be ready for. Engineers, strategists, and pilots alike began asking a single question. If Germany could build a jet like this in ruins, what could America create in victory? When Allied troops captured their first intact Me-262 late in 1945, it was treated like a prize from another world. Engineers carefully disassembled it, studying every wire and rivet. They realized that while the jet was flawed, its design principles were revolutionary. The shape of its wings, the position of its engines, the aerodynamic balance, all hinted at the potential of future flight. In that moment, the jet race began, not in the skies, but in the minds of those who understood what they were seeing. Germany's Me-262 had shown what was possible. Now, it was America's turn to make it real, faster, stronger, and smarter. The war was nearing its end, but the age of air power had only just begun. And somewhere in a quiet hangar in California, a handful of engineers were already sketching the next great leap, the machine that would carry the United States into the jet age and turn the echoes of fear into the roar of victory. When word of Germany's jet fighter reached Washington, it set off quiet alarm bells at the highest levels of command. The Allies had expected Germany to fight with desperation, but not with aircraft that seemed to come from another century. The Me-262 was faster than anything the United States or Britain had in the air. It wasn't just a weapon, it was a warning. And for American engineers, that warning meant one thing. The future had arrived, and they had to catch it before the enemy perfected it. In a small, makeshift workshop in Burbank, California, a man named Clarence Kelly Johnson was already working on the answer. Johnson was no stranger to impossible projects. As the chief engineer at Lockheed, he had designed the P-38 Lightning, a twin-boomed fighter that changed the air war in the Pacific and Europe. Now, he was handed an even greater challenge: to build America's first operational jet fighter, faster and more advanced than the German Me-262. The Air Force gave him just 180 days. Johnson accepted without hesitation. He handpicked a small group of engineers, draftsmen, and mechanics, about 23 people in total, and moved them into a rented circus tent behind the main Lockheed factory. The tent leaked when it rained, the heat was unbearable in the day, and they worked 7 days a week. But they had freedom, No bureaucratic interference, no endless committees. They were there to make history. Johnson named their secret division Skunk Works, a name that would become legendary in aviation. The project's codename was XP-80, and its mission was simple: prove that the United States could master jet propulsion as fast as Germany had. But there was nothing simple about it. Jet engines were still experimental, fragile, and unpredictable. They burned through fuel at alarming rates and generated heat that melted ordinary metals. America's first jet engine would come from Britain, the de Havilland Goblin, designed by Sir Frank Whittle, the man who pioneered jet propulsion. The British, understanding the shared stakes of the war, agreed to send one engine to Lockheed under tight secrecy. When the crate arrived at Burbank, Johnson's team unpacked it like it was treasure. Every bolt, every curve of metal was studied and measured. They couldn't afford to wait for replacement parts. They had to build their own improvements from scratch. Around this engine, Johnson's team designed an aircraft that was elegant, clean, and efficient. A single-engine jet with sleek lines, thin wings, and a bubble canopy offering panoramic visibility. Every decision had one goal: speed. As the aircraft took shape, the workers began to realize they were building something truly extraordinary. The XP-80 was smaller than the Me-262, lighter and less complex. It didn't have to carry bombs or heavy armor. It was built to hunt, not to run. Johnson and his engineers worked day and night, refining every piece. Their mantra was quick, quiet, and quality. Mistakes were fixed immediately. Ideas were tested on the spot, and approval was given on the factory floor, not in offices. By January 1944, the prototype was ready. Its skin gleamed silver under the California sun. Test pilot Milo Burcham, a man known for calm nerves and perfect instinct, climbed into the cockpit. Mechanics stepped back as the British engine spooled up with a rising metallic whine. The sound was new, not the rumble of pistons, but a scream that built in pitch until it shook the air. Burcham released the brakes, and the XP-80 surged down the runway, accelerating faster than anyone had imagined. Within seconds, it lifted gracefully off the ground and vanished into the desert haze. Lockheed's tent erupted in cheers. America had entered the jet age. That first flight was a success, but also a revelation. The jet was unlike anything Burcham had flown. It was smooth, stable, and blisteringly fast, but it required a different kind of flying. Jet engines responded slowly to throttle changes, and once airborne, the XP-80 accelerated so quickly that the horizon blurred. It wasn't just a new aircraft. It demanded a new kind of pilot. Back in Washington, news of the successful flight spread fast. General Hap Arnold, commander of the U.S. Army Air Forces, personally visited the Skunk Works facility to congratulate Johnson's team. Arnold had been among the first to recognize that future wars would be won not just by numbers, but by technology. He saw in the XP-80 the same spark that had once given the Allies radar and the atomic bomb, the power to turn innovation into victory. But the United States wasn't just copying Germany's ideas, it was refining them. Where Germany's Me-262 had been rushed into combat with fragile engines and inadequate pilots, the XP-80 was tested, analyzed, and perfected before deployment. Johnson demanded precision, and he got it. Every vibration, every temperature spike was recorded. Each problem became an opportunity to make the jet better. Meanwhile, across Europe, the Me-262 was burning itself out. Hitler's obsession with turning it into a bomber had slowed production to a crawl. Fuel shortages grounded most jets before they could even fly, and Allied bombers kept destroying airfields where they were stored. German engineers worked in underground tunnels, short on metal and manpower. The Me-262, once hailed as a miracle, had become a symbol of Germany's arrogance, brilliant but unsustainable. America, by contrast, had mastered the art of organized innovation. Factories, suppliers, and engineers moved like gears in a single machine. Once the XP-80 proved it could fly, production plans were drawn up almost immediately. The new jet was given a name that captured its spirit, the P-80 Shooting Star. It represented not just speed, but progress, the kind of progress that could only come from cooperation, not desperation. As the first production models rolled out, pilots were trained to handle the new power they now possessed. Flying a jet was nothing like flying a piston-engine fighter. There was no torque, no vibration, no sense of engine rhythm. Instead, the flight was pure acceleration, smooth, almost unnatural. Veteran pilots had to relearn instincts they'd spent years perfecting. But once they adapted, they described it as liberation. It felt like flying the future, one said. Though the P-80 was ready before the war ended, it arrived too late to see major combat. A few were deployed to Italy in 1945, but Germany surrendered before they could fire a shot. Still, those who saw it fly understood what it meant. The balance of power in the sky had shifted forever. The Me-262 had shocked the Allies. The P-80 ensured they would never be shocked again. In the months that followed, the Shooting Star became the foundation of America's post-war air strategy. It was faster, stronger, and more reliable than anything Germany had fielded. Its design influenced an entire generation of aircraft, from trainers to interceptors. Johnson and his Skunk Works team had not only caught up with Germany, they had leapt ahead. When engineers examined capture Me-262s, they saw what could have been brilliance undone by pride. The German jet had introduced the world to speed, but the P-80 made speed practical. It was proof that innovation, when guided by discipline and teamwork, could achieve what desperation never could. As the desert sun set over California, the P-80 gleamed on the runway, its engine cooling in the evening air. The men who built it watched quietly, exhausted but proud. They had taken a sound, the terrifying scream of an enemy jet, and turned it into something else entirely. Not a weapon of fear, but a symbol of hope. The jet race had begun in chaos, but America had turned it into purpose. And as the Shooting Star climbed into the twilight sky for another test flight, it carried more than just a pilot. It carried the promise of a new age, one where human imagination could soar faster than ever before. When the guns finally fell silent in 1945, the world believed the war was over. But beneath the surface, another race had already begun, a silent war for knowledge. The ruins of Germany hid something far more valuable than territory or weapons, the blueprints of the future. Across bombed-out factories, buried research centers, and abandoned airfields lay the remnants of technologies so advanced they seemed decades ahead of their time. America and the Soviet Union both understood what this meant. Whoever seized Germany's scientific brainpower would shape not only the next war, but the next century. For the Americans, the search began even before the surrender. Intelligence teams, disguised as ordinary officers, followed rumors of secret projects and underground bases. They were looking for anything related to jet propulsion, rocketry, radar, and guided weapons. The hidden engines of Germany's technological revolution. What they found was staggering. Deep inside the Harz Mountains, they uncovered vast networks of tunnels where the Messerschmitt Me-262 and its successor designs had been assembled by forced labor. Crates filled with half-finished jet engines, blueprints, and prototypes littered the tunnels. In Piedmont, they found the shattered remains of Wernher von Braun's rocket research complex, the birthplace of the V-2, the first human-made object to reach the edge of space. But the most valuable discovery wasn't the machines. It was the people. Even in defeat, German scientists represented the most advanced pool of technical knowledge in the world. Men like Hans von Ohain, who helped invent the jet engine, Alexander Lippisch, whose designs would lead to the Delta Wing fighter, and von Braun, whose rockets had terrorized London. All of them knew things no one else did. America could not afford to let this knowledge fall into Soviet hands. And so, a secret operation was born, one that would rewrite the ethics of victory. It was called Operation Paperclip. Under its cloak, U.S. intelligence officers quietly recruited hundreds of German scientists, engineers, and technicians, offering them safe passage and new lives in America. Their Nazi pasts were hidden, their records rewritten. Officially, they were technical experts brought in to help with post-war research. In truth, they were the architects of Germany's most advanced weapons programs. Men who had built engines for the Me-262, designed rockets for the Luftwaffe, and planned aircraft that never left the drawing board. By late 1945, transport planes were ferrying them out of Europe under cover of night. Some went to Wright Field, Ohio, where captured aircraft were tested. Others were sent to military labs and universities. A few were sent to desert test ranges, where rocket experiments began almost immediately. It was a moral gray zone that made many in Washington uneasy, but the logic was simple. If the U.S. didn't take them, the Soviets would. At Wright Field, American engineers began to disassemble the Me-262 piece by piece. The more they studied it, the more they understood how advanced it really was and how much room it had left to grow. Its engines used axial flow turbines, more compact and efficient than the centrifugal types used in early Allied jets. Its swept wings reduced drag at high speeds, allowing stable flight near the speed of sound. Its airframe, though crudely built under wartime conditions, was aerodynamically elegant. The Me-262 was flawed, yes, but its design language pointed toward the future of aviation. The data collected from these studies led to immediate innovation. American manufacturers like General Electric, Westinghouse, and Allison began building new turbojets using German principles, but with American precision and materials. The J-35 and J-47 engines that would later power aircraft like the F-86 Sabre and B-47 Stratojet were direct descendants of those early studies. The U.S. wasn't just copying, it was perfecting. At the same time, another competition was unfolding. Soviet forces were conducting their own hunts through the wreckage of Germany's industrial heartland. They captured entire factories and transported them east. Scientists who had worked on the Me-262 and V-2 were shipped to the Soviet Union under guard. The same blueprints being studied in Dayton were being read in Moscow. The Cold War's arms race had already begun, born from the same wreckage, fueled by the same ambition. But amid this silent struggle for knowledge, the Americans recognized something that the Germans had overlooked. Technology alone does not win wars. Systems do. Germany had built brilliant weapons, but failed to build the structure to sustain them. Its factories were scattered, its logistics broken, its leadership arrogant and divided. The United States, on the other hand, had proven that coordination and discipline could turn innovation into power. So while German engineers brought their expertise, it was the American system that would refine and multiply it. In one corner of Wright Field, a captured Me-262 sat on display, stripped to its frame. Engineers circled it like surgeons, measuring, sketching, and debating. Young technicians leaned in close, their eyes wide with curiosity. This was the future, cold, efficient, and full of promise. Across the runway, test pilots climbed into captured aircraft for evaluation flights. They described the Me-262 as fast but treacherous, a plane that demanded respect. It was like flying a razor blade, one pilot said. But he also admitted something else, that when it flew right, it felt like no other aircraft on Earth. These evaluations became the cornerstone for a generation of American designs. The F-84 Thunderjet, the F-86 Sabre, and even the experimental Bell X, one all carried lessons learned from German technology. But the difference was clear. America took theory and turned it into reliability. Where the Me-262's engines lasted 25 hours, American jets soon achieved 200. Where German fuel burned inconsistently, American refineries standardized jet fuel production. What had once been a desperate invention now became a sustainable revolution. Meanwhile, the arrival of German scientists on American soil changed everything about how research was done. Von Braun and his rocket team were settled in Fort Bliss, Texas, where they began testing captured V-2s under Army supervision. Lippisch, the visionary behind the Me-163 and early Delta Wing concepts, joined Convair, and contributed to the design of future supersonic aircraft. Von Ohain, the co-inventor of the jet engine, worked with the U.S. Air Force to develop turbojet and ramjet systems. Within 5 years, the same minds that once worked for the Third Reich were now fueling America's leap into the jet and space age. But the story wasn't just about technical progress. It was also about redemption. For the United States, the jet program became proof that knowledge, even born from war, could serve peace. Engineers who once studied destruction were now building machines that would explore the skies. The jet that once terrified Allied pilots had become the foundation of freedom's defense. By 1949, the balance of power had shifted entirely. Germany's secret technology had been absorbed, improved, and multiplied. The United States now fielded squadrons of jet fighters that could outclimb, outrun, and outfight anything in the world. The F-86 Sabre, with its swept wings and roaring J-47 engine, became the new symbol of American air power, the perfected evolution of everything the Me-262 had started. Looking back, it was a strange irony. The jet that once promised Germany victory had instead handed its enemies the tools to dominate the sky. The Me-262 was the spark, but America had become the flame. Through discipline, collaboration, and vision, the U.S. had transformed a weapon of desperation into the foundation of its own technological empire. As the 1940s ended, one truth became clear. The world had entered a new age, an age defined not by who had the most planes, but by who had the fastest ideas. And in that race, America was already pulling ahead, propelled by the ghosts of the Me-262 and the brilliance of those who had learned from it. The jet race had begun in fear, but it ended in understanding. What had once been Germany's last gamble was now the engine of American supremacy. The torch had passed, from chaos to control, from defeat to discovery, and the roar that once haunted the skies of Europe was now the sound of America's future. By the dawn of the 1950s, the air war had changed forever. The age of piston engines, propellers, and dogfights fought at 200 miles an hour was over. The new battlefield was altitude, velocity, and technology. The jet era, born in desperation in Germany and refined through American ingenuity, was now fully alive. The world's first generation of jet fighters filled the skies, and in that high, thin air above Europe, Asia, and the Pacific, the lessons of the Me-262 would finally meet their reckoning. At the center of this transformation stood the Lockheed P-80 Shooting Star, the sleek, silver jet that had carried America across the threshold of modern air combat. It had been the answer to Germany's Me-262, a machine that proved not just that America could catch up, but that it could lead. After the war, it evolved into the F-80, a true frontline jet fighter. For thousands of young U.S. pilots, the F-80 was their first taste of the new kind of war in the sky, a world of blinding acceleration, soaring climbs, and split-second decisions. But even as the shooting star took its place in American squadrons, the next generation was already in motion. Clarence Kelly Johnson and his team at Lockheed Skunk Works weren't content with what they'd achieved. They knew the future lay in supersonic flight, in aircraft that could not only outfight the enemy, but outrun the sound barrier itself. The Germans had hinted at it, sketching designs for the Lippisch P.13A and the DFS-346, but they never had the time or stability to make them real. America did, and it was determined to use every advantage it had gained from the jet race to push beyond anything the world had seen. At Edwards Air Force Base, a new kind of pilot was being born, part engineer, part daredevil, all courage. These men flew machines that no one truly understood yet. They faced flameouts, engine bursts, and untested aerodynamics. Among them was Chuck Yeager, a West Virginian with a calm voice and nerves of steel. In October 1947, Yeager climbed into a rocket-powered aircraft built by Bell. The X-1, its orange fuselage gleaming in the desert light. It wasn't a jet fighter, but it was the child of jet-age ambition, designed to do what no one had dared before: break the sound barrier. The X One carried the same spirit that had fueled the P-80. American craftsmanship, scientific precision, and an unshakable belief that limits existed to be broken. When Jaeger fired its engines and the aircraft soared past Mach 1, the shockwave cracked across the sky like a gunshot heard around the world. The barrier that had haunted aeronautics for decades was gone. In that moment, the United States didn't just match Germany's wartime advances. It leaped beyond them, turning borrowed science into mastery. The next step came quickly. By the early 1950s, engineers had refined the lessons of both the Me-262 and the P-80 into something extraordinary, the F-86 Sabre. It was more than a successor. It was the embodiment of everything America had learned about speed, aerodynamics, and control. With its swept wings, refined from German research, and its powerful GE J-47 turbojet, it could fly faster and higher than any jet before it. The F-86 wasn't just a weapon. It was a statement of dominance. That dominance was tested almost immediately in the Korean War. When American pilots took to the skies in their F-86 Sabres, they met their match in the Soviet-built MiG-15, a jet that owed its own design lineage to German engineers captured by the USSR. It was the jet age's first true duel, American precision versus Soviet imitation. Over the cold valleys of Korea, the battles were fast, brutal, and often invisible, jets streaking past each other faster than the human eye could follow. The Me-262 had once terrified Allied bombers. Now, its descendants faced each other above a new continent. Yet this time, the outcome was different. The Sabre's speed, control, and reliability, combined with the skill and training of U.S. pilots, turned the tide. American airmen shot down MiGs at a ratio of nearly 10-1. For the first time in modern warfare, air superiority was achieved not by numbers, but by innovation and discipline. The lessons learned in the smoky hangars of Wright Field and the desert test runs of California had paid off. Behind every victory, though, was the quiet work of engineers who refused to stop pushing. Men like Kelly Johnson, Ed Heinemann, and Theodore von Karman continued to turn yesterday's breakthroughs into tomorrow's standards. They studied captured German data not to mimic it, but to improve upon it. They experimented with new alloys, new fuel systems, and new wing designs that could handle the punishing heat and pressure of near-supersonic flight. The result was a revolution in aerospace technology that reached far beyond the military. The commercial jet age that would soon follow, ushered in by aircraft like the Boeing 707 and Douglas DC-8, owed its existence to those wartime experiments. What began as a quest for military dominance became a foundation for global connection. The same principles that had made the P-80 and F-86 possible made it safe for civilians to cross oceans in hours instead of days. The sky that had once been a battlefield became a bridge. Still, the shadows of the war never completely faded. Many of the scientists who helped propel America forward had come from Germany's dark legacy. Operation Paperclip had brought them out of the ashes, but their pasts remained controversial. Men like Wernher von Braun, once a member of the Nazi regime, would later design the rockets that carried Americans to the moon. History, it seemed, had an uneasy way of turning its villains into visionaries. Yet, if there was one truth that emerged from this tangled web of innovation and ideology, it was that progress is born from persistence, not perfection. Germany's Me-262 had been a glimpse of what was possible, but it was built in chaos. America's response, measured, organized, and driven by collaboration, transformed that glimpse into a sustainable reality. The United States didn't just adopt the jet engine. It domesticated it, refined it, and turned it into an industry. By the end of the decade, America's skies were filled with the descendants of that race against time. The F-100 Super Sabre, the F-104 Starfighter, and eventually the State Route 71 Blackbird, each one a testament to how far the country had come in a single generation. Every new model flew faster, higher, and longer than the last. The same engineers who once looked in awe at the Me-262 were now designing aircraft that could outrun missiles and touch the edge of space. Looking back, it's easy to see the Me-262 as a relic of lost ambition, a machine built too soon for its time. But its legacy lives on in every jet that followed. The Me-262 showed the world what the jet engine could do. The United States showed what it could become. In the end, Germany's overconfidence and obsession with spectacle had given birth to a technology that only its enemies would perfect. When the last Me-262 was wheeled into a museum, its aluminum skin polished to a dull shine, it no longer looked menacing. It looked prophetic. Standing beside it in those quiet halls, visitors could trace a straight line from that machine to the F-86, the X-1, and even the spacecraft that would one day pierce the stars. The war had created monsters, but it had also created miracles. And so, the story of the jet race ends not in the ruins of Germany or the deserts of California, but in the skies themselves. The scream that once terrified Allied pilots became the anthem of progress. The same wind that carried bombers across Europe now carried humanity into the heavens. The Me-262 may have been born of arrogance, but the shooting star was born of resolve. And together, they changed the sky forever, proving that even in the darkest chapters of history, invention can rise from ruin, and the pursuit of speed can become the pursuit of something greater: freedom.